Now we're going to do the second part of the evaluation section. So we're going to discuss the strengths and the weaknesses of the investigation, the limitations of the data, the sources of error, and realistic and relevant suggestions for the improvement and extension. And what that looks like in the exemplar is the following. Oops, there it is. We've talked about accuracy and precision already, so now we're going to compare our percentage uncertainties. So for each number that we can calculate, each thing that we can measure, we should be computing a percentage uncertainty. So, for the spring constant, the gradient had an uncertainty of 6%. This comes from the random error in the readings, so if we have a look at the analysis section where we discussed that, we'll see the percentage error in some of these times squared is pretty big. So what we need to do is we need to reduce the random error in order to reduce these things. So that's what we said here. As you can see from the process data table, a range of uncertainties from 4% to 27%. We could greater number of repeat readings to produce a more reliable trend line. And then we discuss things that are strengths of the method. And one of the things we did is we used a data logger to record a time as opposed to human reactions stopwatch, which has human reaction speed to take into account. We measured the compression distance using a meter ruler, so it was a distance plus or minus a millimeter. We calculated the uncertainty was about 0.5%. This is very small, and if it's very small we can say it's a strength of the method. Similarly with the interrupt card and the measurements of the mass. And the other things we need to do now is we need to discuss the physics. So there's a distinction between the practical issues you faced and the methodological issues you faced. So the practical issues you faced are this experiment was hard to do because I had to hold this thing and it was jittering backwards and forwards. Errors in the method itself that you could legitimately fix by changing the method. Anything methodological is problems with the physics. So I dropped the ball from too high a height, and that meant that what it was doing was it was reaching terminal velocity, and therefore I wasn't measuring the acceleration that I thought I was measuring. Things of that ilk. So if we have a look at the last little bit of this, part of the reason perhaps before our large anomalies here was due to increased friction between the cart and the table, and between components of the cart. So we could use a smaller range of masses so as to reduce the effect of friction, because it would have a smaller normal reaction force and therefore a smaller friction. Now what I haven't done really is I haven't discussed much in the way of improvements. Now we've said that we could take more readings, which is always true, and we could use a smaller range of masses to overcome friction. This is sufficient for discussing the weaknesses and what you might do to improve them. What we also need to do is talk about things that we might do to extend the experiment, and that's not things I've done here, unfortunately. So what could you say? Well, you could say things that you could also measure by using the same apparatus. Maybe instead of measuring the spring constant, you could figure out a way of measuring the coefficient of friction. So that's other things you could measure with the same setup. Maybe you could also say another way of measuring the same thing. So I could measure the spring constant by a Hooke's law experiment, or by bouncing a mass back and forth and using the simple harmonic motion equations. And therefore I could measure the spring constant in multiple ways, and I could compare those things. So that's what it means by relevant suggestions for extension. So improvement, we say how we fix the things in the method that need fixing, so the reasons we have large percentage uncertainties, or the methodological things that are wrong with the physics behind the experiment, and we say what we could do to extend it.